Hello, class. This video will be a walkthrough of the full review quiz for exam 3. I'm not going to work every single problem on that because I feel like we already kind of did that as we went through chapter 3 and chapter 4. What I will do is like talk about how to start the problem, what you need to know, and then definitely work through some of the problems that I think would be helpful to work through. So in Blackboard, you should have seen the announcement on the test. Bring that up right quick. This being our third test, by now, if you took the first two tests, you know how the third test works. The dates are from Monday, November 3rd. That'll open up first thing in the morning, and then it has to be done by basically midnight on Sunday the 9th for your first attempt. The retest will be open basically up to the Sunday before Thanksgiving week. And if somebody's interested, I can even let you take the retest during Thanksgiving week. That's up to you, and I just need to know. But the official due date for the retest is, where is it? Sunday, November 23rd. All right, and just like with the first two tests, I'm assuming most people are going to be taking this online via HonorLock. Some of you are still coming to campus to take the test. That's fine. Whatever works best for you. So all of that is the same as first two tests. Again, I'm not going to have the practice test open unless somebody specifically asks for it. But don't forget that you have those instructions in Blackboard on how to walk through how to do HonorLock. So if you haven't done it since the last test, you may want to just glance through those again for the process. What else? Just like the second exam, you will be allowed one side of one page of notes for this test. Now you don't have to do things like like in chapter 4, we have the Babylonian system, Egyptians, and Roman numerals, all those symbols. Those symbols will be part of the homework problem in MATLAB, so you don't have to get those on your sheet. What else? So just a quick overview of the test content. It's about 25 questions, which is my normal test length. Point-wise, it's half and half between chapter 3 and chapter 4. There are a few more questions from chapter 4, but they tend to be a little bit shorter questions, so they're not worth as many points. The single biggest section on this test is the truth table section from 3.3. That's a quarter of the test points. And then all the rest of the points are evenly split between the other two sections of chapter 3 and the 4 sections in chapter 3. And as I've outlined here, I would say the two biggest skill sets from chapter 3, be able to do your truth tables, which means knowing your language and your symbols on top of knowing the truth tables. And then in chapter 4, we do a lot of conversions between number bases, and that's kind of, to me, that's related to expanded form. So being comfortable with expanded form at other bases is a key to a lot of the stuff in chapter 4. And then if you want to read through that, that's the specific details for that. So we're doing this test consists of 3.1, 3.2, 3.3, and 4.1 through 4.4. All right, so let's jump into MATLAB and start looking through the quiz. Now, one thing I want to point out is I think if you're still passing the course at this point, I think you figured out how to use the quizzes. Some people are still kind of getting used to that. And so the best way to prep for this test is you got the skill check quizzes, you've got the mini review that's required. To take each of these at least once, just like a test. So before you take this test, you should give yourself like 30 minutes, sit down, take that mini review with nothing but you, your calculator, and your note sheet. And you should be using these, and what you miss will tell you, what you're likely to miss on the test unless you figure it out. If you do that for each one of those skill check quizzes and the mini review, then that will tell you what you need on your page of notes. All right, so let's get into the full review and start going through some questions. All right, so and again, just like all my tests, they are in order um that we covered it in class. So the first part is going to be 3.1. And 3.1, that's when we basically introduce the idea that a statement is something that's either true or false, but not both at the same time. We had to translate those into equivalent statements. We also did negations and quantifiers. The quantifiers were all, some, and none. So those were, that's what you have to do at the start of the test. Like, here's a good question. So some A or B, so what would be an equivalent statement? Okay, so then you just basically have to go through and figure out what would be the best. And a lot of times when it's multiple choice, particularly in this translation, my theory is that you should be able to narrow it down to at least a 50-50, if nothing else. So some A or B. So the order matters. So when I'm looking at this, A and B, I would immediately eliminate because they're starting with B going to A. Okay, we're focusing on A in relation to B, so I would start with either C or D. So C, there exists at least one A that is B. That at least one sounds like some. D is there exists at most one A. Well, if it says at most one, it could be one or it could be none. Since it could be none, none is not some. So that would be C. So that's sort of like, that's what I would do, is try to eliminate the ones that, right off the bat that should be eliminated, and then kind of be careful with the other ones. So that's what you're going to see from 3.1. Oh, I need to fix something right quick. Sorry about that little glitch. Um, the full review is the exam plus several other questions. So since it's long, MATLAB had a option for like save for later, which I had checked. But if you do that, then it doesn't let you skip back and forth between questions. So if you're doing the full review for just for practice and not worrying about like the grade on it, then when you're done, don't hit submit. If you want to come back to it later, just like X out of it, and then you can start back where you left off. All right, sharing the screen. Okay. So here we go. Here is the negation of all A R B. That's the other thing in 3.1 is how do you negate something? Remember, negation makes a true statement false and vice versa. So to make an all statement change true false, the negation of all is some. And so all A or B, the negation of that would be some A or not B. That's sort of the challenge in 3.1 for me is the negations and the quantifiers. Without the all, some, or none, that's a little bit straightforward. If you're not negating them, that's not too bad. But the negations and the quantifiers, that's what I would look at for the 3.1. Those are the questions that people are probably going to miss. Because like here, if it's just a negation without quantifiers, it's a little bit more straightforward. Like Mercury is not the closest planet to the sun. Well, if I negate that, well, since it has a not to begin with, just take the not out. So Mercury is the closest planet to the sun, would be the negation of that. Let's see. So here is express the quantified statement in equivalent way, and then write the negation. And negation should begin with all, some, or no. So some integers are not numbers. So make sure you're reading the instructions. In chapter 3, even more so than chapter 2, you really need to slow down a little bit and make sure you're paying attention to what the instructions are. So we want the equivalent to this. So some integers are not numbers. So I'm going to start with the ones that are integer statements. So at least one integer is a number. Here you have to be careful because that would sort of imply if at least one is a number that some are not, but that's implied, not explicitly stated. So B might work, but there's probably a better one. So if we go to let's see, A, all integers are not numbers. Well, see, that says some are not, it says all are not, so that all is not good. So not all integers are numbers. Well, that implies some integers are not, so there's something else. So let's come back to that. So there are no integers that are not numbers. It's a double negation. So that's basically saying that all integers are numbers, but some are not. Not all integers. So not all integers are numbers. Even for me, sometimes I go to slow down. So to me, that looks like that's going to be C. So not all would be some. So not all integers are numbers. That one to me is a better answer than B. Because when it says at least one, that could be all, where this one says not all, which gives us the sum. Now we want to negate it. So if some integers are not numbers, the easiest way to negate it is take out the not. So I would look for some integers are numbers, which is right there. Okay, so that's what you're going to have to do in 3.1. So you're going to have to find equivalent statements. You're going to have, which when nots are involved, that makes, and quantifiers with some, all or none, especially with some, I think that's a little bit more involved. So make sure you go back and I would take that 3.1. If you're a little iffy on that, take the 3.1, 3.2 skill check quiz for more specific examples of these. All right. So then in 3.2, that's when we did our conjunctions, which is ands, our conjunctions, our disjunctions, which is or. The conjunctions are and can be also but or yet. We also did the if then, which is conditionals, and then the if and only if, which is the two-way if then. And so a lot of what we did in 3.2 was translating symbols to English. All right, so here's a good example of this. So no plane can fly faster than 400 miles per hour. Okay, so we want tilde P, and so this is where you have to know your symbols. So that tilde means not P. So choose the statement below that expresses not P in words. So no plane can fly faster than 400 miles per hour. Well, the negation of that to me would be some. So some planes can fly faster than, so that would be D. So, because that says no plane, but as long as at least one can, that would be changing the true or false. So what can you conclude about the resulting verbal statement? Well, first of all, B and D are out the window, right? Because the resulting verbal statement is only partial. There is no partially true or false. It's either true or it's false. Right? To be true, it has to be true 100% of the time. If it's partially true, then it's false. Okay. So it can't be B. The resulting verbal statement is true and false simultaneously. By the very definition of the word statement, a statement can only be true or false, not both. So is the result true or is it false? So the statement is some planes can fly faster than 400 miles per hour. I'm not big on actual plane speeds, but I know they have supersonic planes, which I'm pretty sure is faster than 400 miles an hour. So the resulting verbal statement is true. Okay, this is the sort of thing that you're going to have to do with the 3.2. Determine whether the following statement is true or false. If it's false, make necessary changes to produce a true statement. So one, you got to know how to read this. So that P arrow Q is if P, then Q can be translated as P is sufficient for Q. So this is one of those basic definitions. We don't use sufficient and necessary a lot, but this is, the example I used in class is that, or in the notes is that if you're taking this class, then you're a Carl Albert student. So if you are taking this class, that is sufficient for me to know that you're a Carl Albert student. So this right here is the basic definition for sufficient for. That would be true. So even though I'm not going to ask you too many specific definitions, this is there, you still need to know your definitions to answer these type of questions. All right. So this is the other thing in 3.2 is translating English to symbolic form. So here the P is a crocodile, Q, this is a reptile. And so we want to write if this is a crocodile, then this is a reptile. So write it in symbolic form. The first thing you need to do, if this is, so is a crocodile, that is P. This is a reptile is Q. So it starts with P, goes to Q, so order is important. And this is an if then, so we need the arrow. So we're starting with P. If then is the right arrow, and then Q. What you have to watch out for, if there were knots in here, then you might have a not P or not Q, and we've got that symbol there. But that's some basic 3.2 problems, is translating English sentences to symbol form. And one of the things we talked about, or that's in the videos, and I've talked about in class, for my in-person classes, is when you have these statements, you have to know the order as well. So here we have if S, then not R. So we start with S. So she has a pet turtle. If she has a pet turtle, then it's not R. So then they do not raise monkeys. So that not R says they do not raise monkeys. So then look for anything. So like D. They raise monkeys. There is no not, so it cannot be D. Okay. So process of elimination here. So if S, so it means she has a pet turtle. So notice it can't be B because the if is on not raising monkeys. So it can't be B because they're in the wrong order. And then A is does not have a pet turtle. C, she does have a pet turtle. Well, it's S. So she has a pet turtle. So that's good. Then they do not raise monkeys. Well, that is not R. So this is how you have to go through and do these 3.2 problems. You're going to have them in symbol form and then translate it to English, or they may give you the sentence in English, and then you have to go backwards and translate to symbols. All right, so here's a good one going to symbols. So write the compound statement in symbolic form, assign letters to simple statements that are not negated, and so that are not negated. So when we're doing our P's and Q's, those are going to be like positive statements. And notice that they tell us what P and Q is down here below the statement. All right, and then show grouping symbols. So that means if we need parentheses, we have to include parentheses. All right, so let's work through this. So if it's not true that being Japanese is necessary for being for Tokyo, then it's not true that being American is necessary for being a New Yorker. All right, so what are our statements? So P is represent being Japanese is necessary for being from Tokyo. So up here, it's not true that being Japanese is necessary for being from Tokyo. So what is that in terms of P? Well, it's a not. So that first statement is not P. So if I was showing my work, I would, write the sentence out and then put not P above this. That way I know what that statement is. Then it's not true that being American is necessary for being a New Yorker. But Q is the positive of that is being American is necessary. So that's because of the not, that is not Q. So there's our not P there, and then after the N is our not Q, it's if then. So if it's an if then, we know we need an arrow. We're starting with not P. Notice they have the tilde down here in the answers or in the box. So if not P, and then if, so, and again, we put the arrow after the first statement, but we read that as if not P, then not Q. And again, like I said, if you want to show your work on this, I talked about this in the videos. What I do is like I underline the sentence, the statements, and then I like circle my conjunctions, like the if then. So that kind of tells me that you're kind of tracking that. Yeah. The conjunction, so you have to know the symbols. So now it's only true. So now we're getting into truth tables. So when is P and Q true? Well, this is one thing that, since you have to know your truth tables, I would definitely make sure, like on your page of notes, you have 3 truth tables you have to know. You have to know the truth table for negation, you have to know the truth table for conjunctions with our ands, and then the truth table for disjunctions with our ors. If you have any doubt whatsoever that you're going to memorize those, put those on your paper. So when is an and statement true? They only when they're both true. So the disjunction is false only when, so I'm usually thinking in this terms of true. P or Q is true when at least one of them is true. So the only time it's false is when they are both false. This is, like I said, let me write these down. So for 3.3, you need to know the truth table for not for the negation. And you also kind of need to know how to fill out the truth table input. Remember, negation changes true to false, false to true. Okay. You're doing an and or conjunction, which is also but or yes, yet. You need 4 statements, input rows. True, true, false, false, and true, false, true, false, true, true, false. We're doing P and Q. The only time Q is true is if they're both true. And otherwise, and is false. And then the other truth table is for or. Again, since we have 2 inputs, we need 4 rows. True, true, false, false, true, false, true, false. So or is true when at least one is true. So those are all true because at least one is true. The last one is false because they're both false. All right. You got to have this for 3.3. Whether you have it in your brain or you have it on your paper, that's stuff that you need to know. And you also need to know that, that's a disjunction, that's a conjunction. So you still need to know your names and your symbols. All right. Let me get back to the test. Yes. All right, so in 3.3, we did full truth tables, but sometimes we only did partial truth tables. So let's see here. Determine whether the statement is true or false. If the statement is false, make the necessary changes to produce a true statement. So if one component statement in a conjunction is false, the conjunction is false. What does that mean? Well, this is where it's very handy to have your truth tables written out already. So what you have to know is, so they're talking about conjunctions. We're looking at this truth table. It says if the compound statement is, if one compound statement is false, the conjunction is false. So there is one that's false, so it's false. There's one that's false, so it's false. There's, it doesn't say at least one, but that one's false as well. So if one is false, then it's definitely false. It's a little iffy whether or not it mentions if both are false, because it doesn't say at least one, it just says one. So now let's look at the problem statements and see what the best answer is according to MATLAB. All right. So the statement is false because the conjunction is true only when, so that's it's definitely not A, because if they're both false, then the conjunction is false. So it can't be A. The statement is false because the conjunction is true when one compound. No, that's also wrong, because if one is false, the whole thing is false. So it can't be A or B. So they're saying that, so the statement is true. Now we got to make sure we pick the right one, because the conjunction is true only when both are true. That's it, right? Because that's the only time a conjunction is true, is when they're both true. So it is C. So again, I always think MATLAB does better with skill type problems rather than definitions. This is why you just got to slow down and read them carefully. All right, so a similar question on disjunction. All right, so here's an example of something where we don't need the entire truth table. So how would we do this problem? We get this wrote down on the paper and we'll walk through it. Okay, so we have these two statements. P is 3 plus 6 is 9. Q is 9 times 45, 5 is 45. And they determine the truth value for P or not Q. So how do we determine the truth value? What does that mean? Well, this is basically doing one row of a truth table. And the reason we only have to do one row is we're given these statements. So 3 plus 6 equals 9. We know that's true. And then 9 times 45 equal 9 times 5 equals 45. That's also true. So we don't need the rest of the rows, because we're given two statements and we know they're true or false to begin with. And so now what does we need a not Q and an OR. So this is where you have to know which one to do first. And we talked about the dominants. So like from higher to lower. So it's the or and then the negation. Remember, we're not doing true tables for if thens or if and only ifs. The only thing that overrides this, so or is parentheses. I don't know why my brain wants to make that that V and A. Okay. All right, so when we look at this, we have P or not Q. Which one is the most dominant? The most dominant one is the OR. Okay. So what that means is that's where we get our answer from. So it has to be done last. So we got to do the negation first, the OR second. So I kind of jumped ahead a little bit there. So we got to do the not Q first, and then we do the P or not Q. So what do we know about not Q? Well, Q is true, so not Q is false. Now we gotta do the or for P or not Q, so we don't care about Q. So we're just looking at P and not Q. So when is or true? Or is true when at least one of them is true. We have one that's true. So therefore, our answer is true. So it says determine the truth value of that statement. Truth value of that statement is that it is true. So this is, like I said, this is a partial truth table because we have starting statements. Generic truth tables, it's just going to be P and Q, and then we have to like list out all possibilities. So these are, like I said, I think of these as warm-up questions. All right, so what are like non-warm-up questions? So this one is construct a truth table for the given statement. So P and not P. Now notice here that they've got the columns for us all set up. They've got the input statement. So all we got to do is figure out the right values. So negation changes true to false, false to true. So that would be the first column. And now we're doing and. So when is and true? And is true if both statements are true. So we don't have a row where both of those are true. So that means we're false in both of those. Okay. So this is a pretty typical problem. It's a little bit short because it's just one input statement. But this is, some of these problems, they'll have you fill out the truth table. And that's that. Same thing here. All right. So notice again, since they've got the column set up for you, that kind of shows you the order. So you got to do the or first. And so when is or true? Or is true when at least one is true. So that would be the top row, the second row, third row, all have at least one true for an or. And then that last one's false because neither of them is true. And then you do the negation of that. So we're doing the negation of just this column. So ignore the first two and just change the true false on that column. So it'd be 3 falses and a true. So the key here is knowing like this is X or V. So one, you got to know what the or means, or X or Y, sorry. And then you got to know to look at those 2 columns. Here we're doing negation. We're negating this column. So you're only looking at that third column. All right. So being systematic in your approach is important with truth tables. All right. So here's like a complete problem where you had to translate and you had to do the truth tables. So this is like doing 3.2 and 3.3 together. All right, so refer to the following statement for parts A through C. So you did not do the dishes and you left the garage a mess. Part A, write the statement in symbolic form. Assign letters to simple statements that are not negated. Remember, our basic P's and Q's don't have nots in them. Choose the correct answer below. And they even, they define P and Q for us. So P is do not do the dishes. We can't do that one because it says are not negated. So in our original statement, we can't have nots. So it can't be A. B, you did the dishes. And Q, you left the garage a mess. So it might be that one. C, did the dishes, left the garage a mess. So it might be that one. D, you did not do the dishes. So again, there's a do not in the original one. So it can't be D. So is it B or is it C? Okay, so we did not do the dishes. And so now that's negation of P. B and C both have negation of P. So that doesn't help. Then that one's an or, that one's an and. We'll go back into the statement. That's an and. So there you go. So it would be C. Now, if you really get stuck, and the only people that are watching this video are going to get to see this, how can you help answer that? Well, look at part B. Look at their final answer. They have an and. So yours has to have an and. So it either has to be C or D because those are the only 2 with and. It can't be P or D because of that. We can't put not in the original statement. All right, so then you do a truth table. So the first then they get, and again, they put the order there for you. So do not P. So for not P, ignore Q. You don't care about Q for this column. So just go back to the original P, which is true, true, false, false. So that means now we have two falses, two trues. And then for our final answer, we're going to do not P and not P and Q. So we no longer care about the P column, we just care about the Q column and the not P column. We're doing an and. When is and true? And is true only if they're both true. So not both. So that third row has them both true. And that's it. I don't know about you, but for me, I like to find my rows that are true first, and then go back and the rest of them are false. Unless I'm doing one that has like 8 rows, and then sometimes it's just go row by row. But especially if it's just 2 rows or 4 rows, I kind of like to find the true ones first. All right, use the truth table to indicate the set of conditions that makes the compound statement true or state that no conditions exist. What that means is go back to your final column here, indicate set of conditions that make the compound statement true or state that no conditions exist. Well, for that no conditions to exist, that means all of these would have to be false. But they're not all false. I have this row that is true. So what makes this row true? What made it true was that Q was true and not P was true. So let's see. The statement is true when P is false and Q is true. Well, if P is false and Q is true, then we got true. So they're kind of skipping the negation and they're going back to the original ones. So they're saying that right there. P is false, Q is true, we got true. So it looks like an A to me. Now, the statement is true for all conditions. Clearly, it's not true for all conditions because we have several false, so it can't be B. There are no conditions where it's true. Again, that's not it because we have that row that's true. Statement is true when P is true and Q is false. Well, when P is Q, true and true, Q is false, we get a false. So A is the only answer. So that's sort of, like I said, that at the end of 3.3, you're going to have some translating and truth table problems put together. That's 3.3. All right, then we get into when you start seeing Hindu-Arabic. Now we're in chapter 4. So write that in expanded form. Okay. So expanded form is key to a lot of things in chapter 4. So make sure you know how to do that. Excuse me. So now we're doing 764 in expanded form. So what you have to know is, what does expanded form mean? Expanded form says we're going to do the digit times the place value plus the digit times the place value plus the digit times the place value and so on. Now we're in Hindu-Arabic, so we're base 10, so we haven't got to other bases yet. So this is 764, which would be 7 times 10 squared. 10 squared is 100 plus 60 when we write this out. If it helps, write it out like this first, and then 700 is 7 times 10 squared. 60 is 6 times 10 to the first. And then the 4 is in the ones place value. So don't forget to do the times 1. So if you've done this in the homework, you should be aware of that. And you should also be aware that don't put X's for the multiplication symbols because MathBot will count that wrong. Okay, so that's basic expanded form. Know how to do expanded form. The only difference between this and other number bases, if we were in base 8, let me do the same problem in base 8. So if we want expanded form in base 8, it would still be 7, but now instead of 10 to the second, it would be 8 to the second because our base is 8. And then plus, instead of 6 times 10 to the first, now it'd be times 8 to the first. And then for the 4, remember the rightmost place value is always 1. Doesn't matter what base we're in, because we're doing to the 0 power, 10 to the 0, 5 to the 0. Those are all 1. Okay, so you start with ones and then work your as you go to the left. It's the base to the first power, base to the second power, base to the third power, and so on. All right. We're going to go back to the quiz. This is one of those tests that a lot of the stuff is pretty straightforward. I think if you've done the homework and then like double checked yourself with the quizzes to make sure that you got it. There are some trickier things in this, but a lot of the stuff that I think is should be kind of straightforward. Like here, give the expanded form as a Hindu-Arabic number system. Well, what is 7 times 10 to the fifth? Well, that's 7 followed by 5 zeros. So that would be what, 700,000. 3 times 10 to the fourth would be 3 followed by 4 zeros. So that'd be 30,000, and so on. So this would, and if you look, 10 to the fifth, fourth, third, second, first, and 1. So we don't have any zeros because we're not missing anything. So this would just be 7, 3, 9, 5, 6, 2. And yes, it is that straightforward. All right. The other thing in 4.1 was transloading the Babylonian system. And again, notice that the symbols are given in the problems. You don't have to memorize those. You just have to know how to read them. And it even gives you, like in this one, it gives you sort of the place values. That right place value is 1. Second place value is 60 to the first. Second place value is 60 squared because the Babylonian system is base 60. So what you have to be able to do is you have to be able to translate this. So when you have that less than V, well, V is 1, less than is 10. So that'd be 11. And then VV would be 1, 1. So 1 plus 1. Normally, if it wasn't drop down, you'd put 11 into, and you probably have to put the whole thing, but since this is drop down, we have less than VV. So that's 2 10s, 2 1s, 2 10s, 2 1s. Like if it wasn't drop down, you'd put 22 there. All right, so give the Babylonian number system can be written as Hindu-Arabic. So this one's going to take a little bit more work. So we'll put this one on. Take this one out. Less than V. Less than. All right. So how do we translate this to Hindu-Arabic system? Well, first thing is there is a big space between these two. So that should be, you should know from doing the homework, that means we're going to separate our place values. And what are our place values? Well, place values for Hindu-Arabic, or sorry, for Babylonian, doesn't matter what it is, the first one is always the ones. First one on the right. It doesn't matter for base 60 or whatever. Now we have a second place value, and since we're in the Babylonian system, you have to know the Babylonian system is 60 to some power. So that second column would be 60 to the first. If we had a third column with separated by another space, that would be 60 squared. So you got to know your place values. Okay. That's something that if you think you might forget, again, just put that on your formula sheet. So now what we do is we need to translate this. Again, these are given in the problems. You don't have to memorize it. The less thans are 10s. The V is 1, so that would be 21. And 2 less thans would be 2 10s, so that would be 20. Right, so that's what you do first is translate it. And then you have to put in expanded form. What do we mean by expanded form when we're in Babylonian system? Well, it's going to be the digit times the place value. So it's going to be 21 times 60 to the first plus the digit times the place value. So 20 times 1. That's how we put it in expanded form. Now we want this in Hindu-Arabic. So now we have to do the math. So 21 times 60. Get it typed in, right? 21 times 60 is 1260. It's 20. So that would be 1280. So you're going to have to, so for all our number systems, whether it's a Babylonian in 4.1, or the Egyptian or the Roman numerals in 4.4, you're going to have to convert them from symbols to Hindu Arabic, and you're also going to have to go the other way. Well, actually, for Babylonian, we don't go the other way, you just have to put an expanded form. Okay, so that is 4.1. The maybe the hard, not I don't want to say hard, but like the most work from chapter 4 is going to be 4.2 when you're converting back and forth. And so we have two types of problems in 4.2. You're going to have to convert from a number base to base 10, and you're also going to have to convert from base 10 to a different number system. So you got to make sure that you know the process on this. All right, so this one is convert 63 base 8 to base 10. So how do we do that? Right, so this is something like I said, if you're not for sure you memorize that or have this down, you have your one side of one page of notes, so address that on your page of notes, however you best deem fit. So to convert to base 10, step 1 is we need our place value. Anytime you're converting, doesn't matter which direction you go, you need your place values for your base. So we're in base 8. So the place values are going to start on the right at 1. And then as we go to the left, it's going to be 8 to the first, 8 to the second, 8 to the third, and so on. Okay. Now we only need we don't need these for this particular number because it's only 2 digits. If we had a third digit, we need 8 squared. If we had a fourth digit, we need 8 cubed, and so on. So you need your place values to be able to do this. Step 2, expanded form. I can't emphasize enough the importance of expanded form in chapter 4. So expanded form says, well, that 6 is in the second column, so it's going to be 6 times 8 in the first, and then 3 times 1. But basically same thing we did up here in base 60 for the Babylonian. And then you just do the arithmetic. And that would be 48 plus 3, which is 51. Converted 63 base 8 to base 10. So when you're going to base 10, that is the more straightforward conversion. Because you just need to identify your place values, expanded form, and then some addition, multiplication and addition. Now, going the other way is where it gets messy. So from the homework or from the quiz, this is number 39. They want us to convert 121. Now it's in base 10. We don't normally write the subscript, but I'm going to put it in the notes. Convert 121 base 10 to base 4. So how do we convert from base 10 to a different base? This is where all those divisions are necessary. Still, step 1, we need to get our place values. So start on the right with 1, because it's all, it's 4 to the 0, which is 1. And then as we go to the left, do your exponents, so 4 to the first, 4 to the second, 4 to the third, 4 to the fourth, and so on. Now, since we're going to be doing divisions, we don't want these in exponential form. We actually need them to like the actual number. Let me go ahead and do this. So that'd be 4 to 0, so that is 1. That is 4. 4 squared is 16. 4 cubed is 64. 4 to the fourth 256. So how do you know how many place values you need? Again, if you've done the homework, you've seen this before, but we want the place value that we start with a place value that's not too big. So 256 is more than 121, so that's too big. So we don't want. So that means we're going to have to do 1, 2, 3, 4 divisions. And you always start with the biggest place value that fits in the number. So you come over here to the side. We're going to do 121 divided by 64. How many times is 120, 64 going to 121? If you need your calculator, remember we're only looking for the whole number part, not the decimal. We're going to do something else besides the decimal. So 64 will go into 121 one time. Now you need the remainder. So 1 times 64 is 64. Do the subtraction. So 57. So that 57 is the remainder. Now that 1 is going to be part of our answer. So you might want to circle that now because we're going to need it later. And then the process to get the rest of them is you take that remainder and then do division on the remainder with the next lower place value. So we're going to do 57 divided by 16. So how many times does 57 go into 16? It'll go in 3 times plus some, so it'll be 3. 3 times 16 is 48. So that's a remainder of 9. So circle that 3. You're going to need it later. So again, we just keep doing this until we get all the way down to the left to the ones place value. So we take that remainder of 9, divide by 4. Now we go on to 4 going to 9 twice. Remainder 1. Circle that 2. Now we're going to take the remainder and divide it by the last place value now of 1, which will go in once. All right, now be aware, we could get, if you're doing something like, let's say that the remainder here was 10, and we're trying to do 10 divided by 16. What that means is 16 would go into 10 0 times. So don't say it doesn't go into it, say that it's 0, and then the remainder is the number you have, because then you'd be subtracting 0. So you do this series of divisions. You always start with the biggest place value that will go into here without going over. Now, when you get to the answer, well, how do you do your answer? Well, we know that, in normal number systems, we always start with the biggest place value on the left and work our way down. So we take the biggest place value answer and work our way down. So we start with a 1, and we got the 3 from the next biggest place value. We got the 2, and then the 1. So it always has to go in the order from the biggest division, biggest answer, or sorry, the answer from dividing by the biggest one till we get down to the ones. We are in base 4. All right. So you're definitely going to have to do from base to base 10 and from base 10. So you're going to have to know both of these methods for the test. The only difference, like on a problem like this with a different base, like if we were doing this with base 5 instead of base 4, then we would have, instead of 1, 4, 16, 64, well, the powers of 5 are 1, 5, 5 squared is 25, 5 cubed is 125. So those numbers would be different. So that would change our divisions over here. That is 4.2. You're definitely going to have to do both of these on the test. All right. So once you get into the adding and subtracting, now we're in 4.3. So add the given numbers in the indicated vase. And this is when you have to know when to borrow and when to carry. And again, the issue I think with 4.3 come test time is all your life you've been dealing with base 10. So every time you've borrowed and carried, you've always done units of 10, but now we're no longer in base 10. And so, excuse me. So when you're borrowing and carrying, what you're borrowing and carrying depends on your base. And when you're adding, you borrow, or sorry, you carry once your sum equals that base or higher. And so one of the things I think came helpful in class when we were doing this is do each column kind of off to the side when you're adding. So let's do 2 plus 3. Well, 2 plus 3 is 5. So what does 5 mean? We're in base 4. 5 is more than our base, so we're going to have to carry. So how does the carry process work? I'm a visual person, so I like to do little dots for this. And so we're in base 4. So how much do we carry? Well, so we take 4 of those. That's going to get carried over to the next higher place value. And then how many are left is 1. So when you're figuring out how much is left, you do your base from that number. So this 1 is what's left over. So that 1 goes in the column. This 1 is the carry. So that 1 goes up there. So now do 1 plus 3 plus 2. That's 6. But we're in base 4. So as soon as we get 4 or higher, we're going to have to carry. How much do we carry? Well, 4 of those are going to carry it over to the next higher place value. And then how many are left over? Well, 6 minus 4 is 2. What that means is in the original column is the 2. And then we carry a 1 over into the third column. And that third column, we just have 1 plus 0. So it would be 2. Or sorry, 1. 1 plus 0 plus 1. All right, so when you're adding in a different number base, what you have to know is that you carry over to the next higher place value when your sum is equal to or greater than your base. And since we're only adding 2 numbers, you're only going to have to carry 1. You're never going to have to carry 2 or 3. You'd have to have like 2 or more numbers to do that, or sorry, 3 or more numbers to get that. There's one of those in the homework, but I didn't put that on the test. All right, so and what goes in that column is how many are left over after you carry over, and then you carry the 1. So that's adding. Right. So we could also do this with subtraction. Let's do the same numbers with subtraction. Okay, so how do we subtract? Well, you have to, on subtract, have to know how to borrow. Okay. Because we can't take 3 from 2. So the borrowing, the initial thing is just like with base 10, you're going to go to the next higher place value. You're going to subtract 1 because we're going to take 1 of those place values. But now here's the key on this is what do we add? You're used to putting a 1 there because you borrowed a 10, so you added a 10. But now we're borrowing 4. So what you have to do is add 4 to that number. That is the key for subtraction. So now we have 4 minus 3, which is 1. And then 2 minus 2, which is 0. And we're done. So for other number bases, you have to know when to carry and how to carry. Like what, like I said, we're typically carrying over 1 and then like what's left. Okay? And then for subtraction, when you have to borrow, the key here is how much you borrow. If this was base 6, we would have been borrowing 6. So I would have added 6 to that. If this was base 8, then we would have added 8, and then that would have been like 10 minus 3, so that would have been a 7. All right. So on the test, definitely going to have at least one of each of add, subtract. But that's 4.3. And then the 4.4 stuff, that is the early number systems. That's going to be the Egyptian and the Roman numerals. Okay. And like I said before, you do not have to have these symbols memorized. They will be on the test itself. And so how do you translate that? Well, spirals are 100, and I've got 1, 2, 3, 4, 5, 6 of them. So that would be 600. Those are, they call those the heel. So those are 1, 2, 3, 4, 5, 6 of those. So 6 tens, so that would be 60. And then 1, 2, 3, 4, 1. So that would be 664. Egyptian, I think, is pretty straightforward. Again, you're going to have to go both ways. Now, if you're translating from Hindu Arabic into Egyptian, it is going to be multiple choice. You don't have to draw them. And so, but again, go by place value. So this is 322. So this would be 300 plus 20 plus 2. So start with the 300. So hundreds are the spirals. So you need 3 of them. Well, right there. So that gives you the 300. That would be 3,000. This one's backwards. Remember, in Egyptian, we do read from left to right. So these are starting with the small place values going up. That's not, those two middle ones aren't proper Egyptian. You always start with the bigger place values and work your way down, just like we do with our number system. So this one, that's the 300, that's the 20, that's the 2. Yeah. All right. Egyptian, pretty straightforward, I think. All right, so for Roman numerals, this is where you have to know, I think the key on Roman numerals is knowing when to subtract. And so when we have XC, do we subtract or not? Well, first of all, what is the X? What is the C? Again, you're going to be given this table. You don't have to have it memorized. X is 10, C is 100. So when do we add? When do we subtract? And so for Roman numeral system, we always read this from left to right. So so what we have here is this is increasing. So if it increases from left to right, that tells you that you have to subtract. If it decreases or stays the same, then you just add the values. Okay, so what this means is since we're increasing, we're going to subtract them, and when you subtract, it's only that pair of numbers that increases. So this is just 100 minus 10, which is 90. As opposed to if we were the other way, Cx, which would be 100 and then 10, since those are decreasing, those you add. And so the other thing is when you're subtracting with Roman numerals, there's always going to be either a 4 or 9 involved. If there's not like once we translate the other way, if there's no 4 or 9, you don't have to worry about subtraction. That one's kind of short. So let's get a longer one. So here's one from the test. It's 3 C's, XLVI. Okay. So from the chart, the C's are hundreds. So it's 100, that's 100. Oh, I don't want to put the plus yet. I want to wait and see. So we have 3 hundreds. X is 10. L is 50. V is 5. And I is 1. So the first thing I do after I translate them all is now, is there any subtraction? So for subtraction does any pair increase in value? So we're good until right here. So when you have a subtraction, put a parentheses around it because those two are the only ones we're going to subtract. So that 1050 means 50 minus 10, which is 4. There is no other place where it increases, so this is all addition. So that would be 300 plus 40 plus 6. So 300. Oh, sorry, on the phone there. Sorry about that interruption. Where were we? Oh, yes. So we were translating this. So we have the 300, the 1050 means since it increases means we have a 40. And then, so everything else is addition. So we have 346. Okay, so on your test for 4.4, you're going to have Egyptian number systems. So know how to go both ways with Egyptian number systems. And you're going to have the Roman numerals and have to go both ways. So we've started with Roman numerals, went to the Arabic. Let's do one where we go the other way. So for example, 219. So when I'm going to Roman numeral system, first thing I do is subtraction going to be involved? The two times you know you have to subtract is if you have a 4 or a 9 anywhere in the number. Listen, if you don't have a 4 or 9, everything's adding. It's a little bit more straightforward. Yeah. So that's the first thing I do is identify that, yes, I am going to have to subtract. Then what you do is break it up by place value. We have 200 plus 10 plus 9. Now we need the symbols for this. And so in Roman numerals, C is 100. So that would be CC. 10 is X. Now, how do we get 9? Well, to get 9, we have to do 10 minus 1, which that 10 is X, 1 is I. Now, remember, when you're subtracting, it's increasing, so it basically has to go backwards. We would write 10 minus 1. For theirs, we need to do 1 minus 10. We need the I first and the X second. C, C, X, I. So anytime you subtract, those got to be backwards. So that don't do 10, 1 because then you're doing 11. But if you do 1, 10, that's increasing. That tells us it's subtraction. All right. So that's what you have to do for 4.4 is both ways on Egyptian number systems, both ways on Roman numerals. And that's the test. All right. So let's see what else. So this test is due sometime between Monday the 3rd and Sunday the 9th. If you want to meet with me like over Zoom to go over anything, just send me an email. And if you're having honor lock issues, again, first thing for honor lock issues, contact honor lock support. They're going to be able to help you more than I am most of the time. And also, if you think you might have honor lock issues, don't wait until Sunday to take your test and then try to contact me. Start earlier. And so that way, if we have issues, we can figure out a workaround. All right. Good luck. And I'll see you soon for next year.